Good morning, my dear students. Welcome back to this session on cable subjected to point loads. Last session we have started solving this problem. Now let us continue the solution process. So we have completed all these steps like finding H value and finding VA, VD value, and also along with that TCD value. Okay, so now let's proceed for other unknowns, like what we are left with. So portion AB tensile force is left over and portion BC tensile force is left over. And what is the H value? These are the unknown values to find. So for that, you have been given some procedure. So from joint A, to calculate TAB and theta AB. It's the next step of solution. Okay, so let's take further down the screen. Okay, so let me just pull it down further. Okay, so little more. Okay, right now we are working with giant A free body diagram. So I shall cut this cable EAB. So let's take EAB free body diagram. Okay, so this is something like axis, and this is going to be VA value, and this is going to be H value. Right now this will be TAB. So TAB, and this is theta AB. Okay, right, you know VA value 5.571. Let's write it 5.571. What about H value? What is H value? 4.072. 4.072. Okay, right. So now we have two unknowns and we can write two equations. This is giant here. So just write sigma fx0. What is sigma fx? The component of this one, TAB cos theta, and component of this one is vertical component. You will be using this one when you write sigma fy0. Sigma fx0 is TAB cos theta, TAB cos theta AB is equal to, it shall be equal to 4.072, or TAB cos theta AB minus 4.072 is equal to 0 will also give you the same. So it will be 4.072. Now if you write sigma fy0, what you get? This is TAB sine theta. So TAB sine theta AB is equal to value 5.571. Okay, so now you have got two unknowns, two equations. So you shall finally solve for two unknowns theta and TAB. So how we do that? It's by very simple way. So let me divide. Say this is 1, 2. So 2 by 1. 2 divided by 1 if I do. What do you get? Sin TAB gets cancelled. Sin theta by cos theta. Nothing but tan theta AB sin by cos, right? Is equal to 5.571 divided by 5.571 divided by 4.072. So what will be this value? 5.571 divided by 4.072. This is 1.368. 1.368. So what is theta AB? Tan inverse 1.368. So let us do the tan inverse 1.368. 53.833 degree. So 53.83 degree. Or else one decimal is also okay. Can manage. Okay. So 53.8 degrees theta AB value. Now if you want TAB, substitute this theta in any one of this. So let's substitute it in 1. So TAB is equal to 4.072 divided by cos 53.83 degree. So it is 6.9. It is actually 6.899. So I will take it as 6.9 kilonewton. This is TAP value. Okay, so got it. So we have taken giant A free body diagram and TAB cos theta AB applying two equilibrium equations. So we have got two equations and we have got two unknowns theta and TAB. So okay, so that is the next step that we have taken. Okay, right. So TAB theta AB we have found. From theta AB you can calculate H value. Let us see how it is. So we know theta AB value, that means this value you have just calculated. So let us try to formulate this one. So this is H and this is 2, right? So tan theta AB is equal to H by 2. Okay, from that you can write. So tan theta AB is equal to H by 2. So what is theta AB? Substitute in this one. So H is equal to 2 times tan 53.83 degree. Okay, right. So do that. So tan 53.83 into the tan 53.3 value is 1.368 into 2. So 2.736. So H value is 2.736. 6 meters h value. Okay, so that is how it is. Now what is left over? The TBC value. Next segment. So from joint BRC you calculate TBC. Okay. So either joint C you take or joint B you take. You can get the value of TBC. What is left over? Okay. So if you want, you can use either joint B or C. So let's go for joint B itself. So free body diagram of joint B. So break this cable, free the joint. So joint B free body diagram. Let me write it. So okay, just a rough diagram. I mean, so vertical line, reference lines. So this cable is TAB. That is something like this. So TAB value we got, that I'll write 6.9. Now this angle theta AB is equal to this angle. Opposite angles are same. So that's why this angle is theta AB. What is theta AB? 53.83. This is 53.83. Okay. Right, now what? Vertical 3 kilonewtons. Vertical 3 kilonewtons. Next, there is a cable here. What is called TBC. TBC. What about this one angle? Theta BC, which is unknown value. Right, because if you want theta BC, you should know the level difference between B and C. That is not given. So if you can get this height, then only you can perform this, because you know this is 2 meters distance between BC. So only if you know the level difference, then only you can get this angle. So we are not able to do it by the geometry. We'll do it from equilibrium. Okay. Right. So what do you do it here? So I get sigma fx0 and sigma fy0, same way of applying equilibrium equations. So from sigma fx0 if you write. So TBC cos theta BC is equal to 6.9 cos 53.83. What is that value? 6.9 into cos 53.83, 4.072. 4.072. What about sigma of y0? So vertical force. So TBC, I'll write it here. TBC is the component of this one. TBC sine theta BC, and 3 is also in the same direction. So I'll write plus 3 is equal to the component of 6.9 is vertical one is like this. So 6.9, I'll write the final value 6.9 into sine 53.83. So 5.57 value. 5.57 is the value. So what is TBC? No? The constant that we will send that side. So sine theta BC is equal to minus 3, right? So it is 2.57. 5.57 minus 3, 2.57. So you got this now, and you got this. So it just like this dividing 2 to 1 or 1 to 2, 1 divided by 2 or 2 divided by 1, you will get theta value, and substituting theta, you will get TBC value. I'll do that. Okay. So let's take this as equation 3. Take this as equation 4. So go for equation 4 by 3. Why you are doing like that? Why not 3 by 4? You can do 3 by 4, but because you get cos divided by sine, you get cot theta. So cot is not there in your calculator. You have to perform again 1 divided by tan. So that's why I am doing it. You have tan readily available in your calculators. So that's why we are doing 4 by 3. I mean sine by cos is always preferred because you are using your calci. Okay. So 4 by 3, always prefer sine by cos. Okay. So that will be giving you TBC and TBC cancel. Sine theta by cos theta is tan theta BC is equal to 2.57 divided by 4.072 is 0.63. 0.631. So theta BC is equal to tan inverse of, so tan inverse of 0.631, 32.25 degree, 32.25 degrees is the angle theta BC. Okay, now you substitute this theta in 3 or 4. Okay, so you get TBC, tensile force in the middle segment, is divided by, as I substitute in 3, so that is 4.072 divided by cos theta BC. So cos 32.25 degree. So you get 4.815 kilonewton. Okay, so this is the tensile force in the middle cable. So now if you just look at the solution what we have done overall, so we have found theta AB, we have found the TAB, we have found the H value, we have found tensile force in the last segment of the cable CD, this CD, and also we have found vertical reaction at D, found vertical reaction at A, we have found the theta BC, theta of middle segment, and also we have found H value, okay, right, and finally TBC. So these are all the findings from these procedure. Okay, so many, 1 2 3 4 5 6 7 8 9 values, okay, are being solved. So this is how you are able to solve a problem of uh, a cable having supports at different elevations. You can solve it by step-by-step procedure like this. Okay. So this is how the solution is, right? So practice this problem. If you have already done it, you check with this solution, okay, whether you are getting the similar values uh, as that of mine, right? Okay, right, thank you. We'll come back to the other part of this problems, right? So next session we will be dealing with cable subjected to uniformly distributed loads. Okay, right. Thank you.